Welcome to the third video in our series, Calculating Application Match. In the last video, we looked at Chicago's research-based framework for college access and learned how to write formulas aligned to that framework or a similar one to assign a roster of students to college access subgroups. In this video, we're going to take this concept one step further and learn how to use formulas to evaluate an individual application for how good of an academic match it is between student and institution. Before we get into that technical demonstration, you may be wondering, why do we place an emphasis on match applications? What is the reason for considering a match application as more important or more desirable than any other application? First, remember that a student's match level represents the most selective type of college where they have a good chance of being accepted. Now, obviously, students can and do apply to colleges more selective than their match level. And in extreme cases, it becomes easier to understand why this is a less desirable type of application. A student with a 1.7 GPA, for instance, who applies to a college with very competitive admissions, is so unlikely to get accepted that taking the time to complete this application wasn't a good use of their time and isn't actually helping them continue their education after high school. But what about students who apply to colleges less selective than they're qualified for? They probably stand a great chance of being admitted, so what's the downside? The answer to that lies in a different outcome that comes far downstream of the student's senior year, but that we should care a lot about nonetheless. And that is the student's chances of completing college. In general, more selective colleges in the United States have higher institutional graduation rates than do less selective colleges. Now, there are exceptions to this, but these maps show post-secondary institutions in the United States. The green dots have graduation rates above 50%, and the red dots below 50%. And you can see that the maps with more selective colleges have a lot more green, and the maps with less selective colleges have a lot more red. In addition, research has found strong institutional effects on a student's chance of graduation, even when students are well prepared academically when they arrive at college. So while it might make intuitive sense to assume that a student who earned excellent grades and test scores in high school will thrive at a college that's below their match level, the research suggests that they actually stand a better chance to graduate if they enroll at a more selective college with a higher institutional graduation rate. Now, with all this said, academic match is just one thing to look at in a college search. Financial aid, majors and programs offered, the character and feel of the institution, all of these factors and many, many more can mean that a specific college is a better or worse fit for a specific student. So when it comes to final decisions, by no means is it always the right thing to do for a student to optimize their choice based on match or on graduation rate. But we think it's important that these be part of the conversation, especially during the application stage, and that counselors use match applications to guide their Tier 2 interventions. So let's get into the technical details of how you categorize applications by level of academic match. Okay, let's begin to look at some techniques for working with applications data. I have some raw applications data in front of me, again, not real students, just to demonstrate how to start to work with this type of data. Compared to the last demonstration video where we were looking at a simple roster of students with their directory identifiers like their name and ID and their academic qualifications, and we were focused on how to calculate the college access subgroup they belong to from their academic qualifications. As we start to look at applications data, our data set itself is more complicated in at least two ways. First of all, we have more information in an applications data set because in addition to just data about the student, we're beginning to have some data about a specific college they've applied to. So we'll have to have at least one variable or some set of variables that identify not just the student, but the specific college. The other way that applications data is more complex is that in order to fully capture the picture of applications at your school, it has to have many more rows. So the roster we were working with in the last video would have one row for each student in your senior class. In order to capture applications data, usually in the raw format, you'll have one row per college that a student has applied to. And so as you'll see with the case here for my first student, if that student's applied to 7 or 8 or 9 colleges, they should show up in 7 or 8 or 9 separate rows in our applications data. And while their academic qualifications of GPA and test score should be the same for each instance of the same student, the college that they've applied to is of course going to represent each of the colleges where the students applied. And so this type of data set compared to our roster, it's not only longer, it's not only that it has more records, that would be a pretty easy additional level of volume or complexity to deal with. Applications data also tends to be more challenging because operationally it moves very quickly throughout the school year, especially at certain points in the school year when there's the most application activity going on. So even if you saw the last technical demonstration and weren't fully convinced and thought, when I see my roster of students, I can sit down with my roster of students at the beginning of the year and look up their access one by one. It might be more time consuming. But with applications data, since that data is literally shifting and moving under your feet at all times during the school year, even more so we want to lean on technology to calculate not only the student's access, but the quality of the academic match between student and college. So this is the data in my raw form. I want to show you a more transformed version of this data that starts to do some of these comparisons. Now, in the last video, we explored a little bit how to write the actual formula. And this is the same formula that we demonstrated from the last video. It's populating with the student's college access level, and of course in the same way that's derived from the academic qualifications variables that you see in this data set here. But now that we have this college variable, in order to see whether or not any given application is a match, we not only need to know the student's access, we need to know the selectivity of each individual college they've applied to. And then moreover, we need to make a comparison between those two things in order to tell, is this a match application for this student? And so you can see in this sample data, the student's access category, then there's a separate column that has the same levels to it and the same color codes, except instead of reporting on the student's access, this is looking at the college they've applied to and coming back with that selectivity rating from the Barron's profile of colleges. Now, the way that I get that in this tool is to have a separate database, which is a more static database, a separate table full of as many colleges in the country as we can gather data for, that includes their selectivity category. And you see that I'm also pulling over some other data that we think is interesting or good to know, good to be part of a conversation about this particular college application, and that's the college's institutional graduation rate. Now, I'm not going to demonstrate, as I did in the previous video, the formulas that are used to pull that information about the college in. The formula is called a VLOOKUP, and there's a whole world of great documentation out there about how to use that function. I'm not going to walk through it as slowly as we walked through the logic functions in the previous video. But you can see it in cases where the student's college access level matches the selectivity of the college. I have a third category here, which is making a comparison between those two, and where they're the same, it's resolving that green category of this is a match application. This is an application where the selectivity of the college meets about as well as it can the academic qualifications of that student to get into a selective college. Now you see in that column, I have a couple other ways to designate applications. It's not just match and not match. We use a 5-level system here, which starts at match, and then these yellow categories are either reach or safety. And then there's a couple of red categories as well that are called too safe or too selective. And to show basically what those categories align to, here's just a simple logic model that shows how any given application is processed and categorized in terms of the quality of application match. So for instance, this left column is a student with access to, and then it has different possibilities for what their access rating is. And then along the horizontal axis of this grid, it's saying applying to a college that is, again, has the 5 possibilities. So if a student with access to a selective college applies to a selective college, these formulas would call it a match application. And you can see if that application is either more or less selective than the student's access level, then it will code it as either safety or reach, but still in that yellow zone of close to a match. And then applications which are more than one step away from the student's access level on that framework are coded in one of those red categories of either too safe or too selective. Now, the second step of being able to do this type of transformation is really key to what we've argued is the purpose of this type of analysis, which is to allow this data to inform that second tier of college application interventions. And there's one more transformation step that's very key to being able to do that, and that's to essentially pivot this data so that it's coerced back into a structure where each student is appearing on one row. The technical strategies you can do to accomplish that is if you're working in Excel, there's a function or a tool called a pivot table that allows you to reshape the data in this way. I'm working in a Google spreadsheet, and there's a function in order to do this called query. And that's a helpful one for being able to reshape this data. So you saw on my raw and on my somewhat transformed version of this data, there was still one separate row, not just for each student, but for each college application. And now that I've reshaped it through this pivot process, I've turned that data back so that each unique student ID only appears once again. And when I read across from left to right, I can see about each individual student what their access level is, again, that same categorization. But then the number of college applications they have within each of these of those 5 levels, from too safe to too selective, and with safety, match, and reach in between. Now, we've argued that using data, one of the main purposes to use data is to identify specific students who are in need of help. So just to model quickly how that's done, let's say that it's during that window of the year when the focus of your Tier 2 supports is on the most selective students. What I can do with this pivoted data is filter the student access level by very selective. Because again, only students in that category would even be considered for Tier 2 application support at a certain time in the year. And then what you're able to do with this table is use your knowledge of where you are in the timeline and your own sense of priorities to set some criteria. It's not just that I'm going to go after every student with very selective access. We want to target the ones whose mix of applications at this point in the school year makes us a little nervous that this student might need to complete some more applications or might need a little bit more advising support from a counselor. So the way I can narrow in on those students most in need of help is I can filter by either their number of match applications or maybe their number of total applications. So let's just say I'll filter by any student who has 1 or 0 match applications, and I did that by just applying the filter at the top of the column. So after I've done that, I'm looking at a list of maybe about 15 to 20 students. If that's still too many for me to handle in my capacity for Tier 2 interventions, maybe I can apply a second filter of saying the student has 4 or fewer total applications. And those criteria are things you can adjust either to meet your capacity to give Tier 2 interventions, or based on a specific criteria that if the student is not at least at this criteria at this point in the year, I'm worried about their mix of applications and their application activity, and therefore I'm going to target them. So just applying some simple criteria, I've narrowed my list down to less than 10 students, but I can adjust that criteria either focusing on different access levels or different numbers of match and total applications to find the students that are best positioned to benefit from some advising at this point in the year.